Hey, this is Mark with a quick update showing a couple new features to IQEngine, both Python related. The first one you can find if you go to a spectrogram page. On the left, you'll see this Python snippet. And this is code that will run on the signal after the filtering, but before the FFTs. And right now, I have a little example snippet that doesn't actually do anything to the signal. It multiplies it by 1. But if we divide by 10, from this point on, the signal as you fetch it from cloud or read it from a local file will have this snippet applied to it. And the way it works is X is the original signal, and then you manipulate X, and whatever X is at the end of the snippet is what gets used for the FFTs. And this is all running within Python, so any NumPy or whatnot code will work. It just has to remain in the same format by the time you're done, and also the same length currently. It makes it a little slower to load files. In fact, if you open up the console, it'll tell you how long the Python part took. But it's really not too bad. So feel free to play around with that. Maybe we can get some more interesting examples here. If it's blank or it's set to the default, it doesn't actually run any Python. So, full speed. So if I just open a new one, even though it has a snippet here, it's not actually running it. Okay, so the next feature is more of a utility kind of thing. It's definitely education oriented. It's a signal generator where you can generate signals in Python and then save them as a siggen recording. So this is the interface here. It's pretty neat. So you have a web-based Python editor, and it's also using pyodide to execute the code. And on the left is the code that generates the signal, and I've got a little example here that generates a tone, some BPSK, and then some noise. And then on the right, we have the code to generate a power spectral density, time domain plot, IQ plot, and spectrogram plot. So the way it works is you hit run, and it runs all the code, all 4 plots. Everything runs. Now, the first time you run it, it takes several seconds, but then each time after, it's pretty quick. And under each of these tabs, we now have the plots that corresponding to this code. So time, frequency, IQ, and spectrogram. And, we can change anything here. You can edit this and just click run, and then you can see the axis label changed. So it's essentially just concatenating all of these 5 editors together. And then under the hood, there's a little bit that's done to get the plotting working as images in JavaScript. But right now, so this is currently all that's implemented. The next step is to add a little way to save the final signal as a siggen data file, which that part's easy. But then I also want a form you can fill out for the meta file, like specifying, the sample rate and frequency and all that kind of thing. And then you would hit a button and it would give you the meta file and the data file as a download. Now, the other idea was to have different starting examples, like different kind of signals implemented in Python using a drop-down menu here, and then a way for other people to add their own examples through a PR without having to mess with JavaScript. Now, how this works, so I used the code mirror library to do the VS Code looking editor, which is quite nice. It's very little code under the hood on our end to get this working. And then it uses pyodide to actually run the Python. I would recommend checking out pyodide. It's a pretty cool library, and I'm sure it'll only get better over time. I set it up with a VS Code theme. And if you're interested in learning more about how to simulate different signals in Python, definitely check out PySDR. It's a free online textbook I made, and a lot of those code examples come straight out of PySDR. Other than that, You know, we're looking for more folks to get involved. There's definitely more people involved now, but we're still looking for more, both developers and users. Even if you don't know any JavaScript, there's always something to work on. And that's all. Thanks.